Hey everyone, Mr. Hisco here with Houlton Southside's after school program. This year we're doing things a little bit different. Normally we have our health fair where you can all come in and view our students' projects and our community members' presentations, but this year we've had to change things up. We have made it completely virtual, and I want to say a huge thank you to my staff for making this year doable for our students most especially. So before I go any further, I'm going to end there and I'm going to show you our presentation. I hope you enjoy it.
Good afternoon, kiddos. Welcome to my kitchen. My name is Mrs. Potter. I'm the Culinary Arts Instructor at Region 2, and I'm here to talk to you about healthy snacks. So today what I thought I would do is demonstrate just how easy it is to make a healthy smoothie. You can put anything in it. If you don't like vegetables, it's a good way to hide them because you taste the fruit, not the vegetables. But today we're just going to do a simple one. So what I've got here is yogurt. This one is a plain, non-fat yogurt. I was going to get a vanilla one, but I couldn't find one, so this will work. I'm going to put that right in my little mixing container. And I'm going to add, since this is not vanilla and there isn't a lot of flavor to this yogurt, I'm going to add a little bit of vanilla to it, just to give it a little more flavor. I'm also going to add a little sweetness, I took some berries that came with our lunch today that some of the kids didn't eat. So I thought maybe some nice sweet strawberries would add a little flavor to it, a little sweetness. I also like to use frozen berries because that way it kind of comes out like a milkshake, so you feel like you're really having a nice treat. So I've got some fresh frozen blueberries that I'm going to add. And I've also got some fresh frozen raspberries I'm going to add. And then to finish it all off, I'm just going to add a little milk because the frozen berries make it quite thick and we want to be able to drink it. So I'm just going to add a little low-fat milk to it. And that's it. And now I'm going to take it over and I'm going to put it on my Ninja and I'm going to blend it up. All right, so here I am. I've got my cup. I'm going to put my Ninja blades on it. If you guys are using anything like this at home, please be careful because these blades are super, super sharp and I would hate for anyone to get cut while they're using it. And there we have it. A nice, yummy, healthy smoothie. It's drinkable. You could also pour it in little cups with a popsicle stick, put it in the freezer and make freezer pops out of it. Super healthy, a good way to get your vegetables if you don't like them, fruits in you, your dairy, just an easy, healthy snack for you. Have a great day, guys.
And it develops social skills.
It supports literacy and numeracy.
It develops motor skills.
It's calming for children.
Encourages creativity and promotes playtime.
everyone, my name is DJ Norton. I work at the Houlton Fire Department, and I'm here today to talk to you about smoke detectors. The NFPA, the National Fire Protection Association, has a saying, hear the beep where you sleep. Did you know that half of home fire deaths are fires that are reported at night between 11 p.m. and 7 a.m. when most people are sleeping? So hearing the beep where you sleep is pretty important. There's a few different types of detectors you can get. This one's a self-contained detector with a battery already inside it. To install it, take it out of the box, put it on the backer, give it a twist, and that activates a detector. The other ones have a 9-volt battery, and there's ones that are hardwired into your home electrical system that have the 9-volt battery as a backup. These self-contained ones have a 10-year lifespan. 10 years from the date on the back, you would throw it away and you would get a new one. Now your battery, you want to replace them twice a year, once when you turn the clocks ahead and once when you turn the clocks back. Testing of your detector, you want to push this button on the front. You want to test them once a month. Push this button on the front for a short period of time and your detector should alarm telling you it's in good working order. You should place a detector in each bedroom of your home. You should have one on each level of your home, including the basement. You can install it on the ceiling or on a wall, about a foot down from the ceiling if it's on a wall. And if it's on a ceiling inside a bedroom, it should be 1 to 5 feet away from the doorway. Detectors are not supposed to be painted. There's not supposed to be stickers on them or anything like that. Also, you can maintain them by using a vacuum to clean them or an air compressor. With the detector, you should have a fire escape plan, 2 ways out of each room of your home, a safe way, effective way out of your home, a meeting place outside where your family can all be safe and accounted for. Call the fire department when you're outside and do not return back inside.
The bridge yoga pose is a great front hip joint opener. It also strengthens your spine, opens the chest, and improves your spinal flexibility. This pose brings many benefits to your body, such as the relief from stress, anxiety, can't sleep, and it can help with depression.
The downward dog yoga pose lengthens and decompresses the spine, stretches the hamstring, strengthens your arm, flushes your brain with fresh oxygen, and calms your mind.
The Warrior One pose is a great pose for those who have a hectic day at work and just need to relax your body and mind. While in this pose, you are strengthening your legs, you're opening your chest and shoulders. The effect out of this picture on temperatures, it strengthens your muscles of your knees and feet, it strengthens your shoulders and spine, and it improves your focus.
The triangle pose might sound like another easy pose, but it is not. Your back has to be aligned properly, and one at your hip.
Hello, I'm Sean Gillen, Sheriff for Aroostook County. Today I want to talk about what you can do to change the world. You being kind to other people and other people being kind to you will change the course of the world. As you may have seen on the news or heard people talk, that there's a lot of people that just aren't being nice out there right now. You need to be a lifeguard of some sort. And if you are seeing somebody that is struggling, that they're maybe being made fun of, or maybe they're not being paid attention to, you need to throw them a lifeline, and you need to be their friend. You need to let people know that they matter. Their feelings matter. Or you just going up to them and talking to them could make the difference, all the difference in the world. And that's what I'm talking about, making a change, making a difference in our world. Being that lifeguard, going out there and throwing people a lifeline. Because someday you may need a lifeline, and you're going to be wanting somebody to throw one to you. I'd like to talk about 3 words: dream, believe, and trust. In order to change the world, you need to dream big. You need to dream about what you can do to change the world. What do you want to do? You need to believe in yourself. You need to believe that you can do it. And then you need to trust. You need to trust in yourself, and you need to trust other people to help you along the way. And I believe those are the 3 key words that will help you succeed in making the world a better place. And I'd like to close by telling that you have the power. You alone have the power to make a change in the world. You have the power to stop bullying if you are. You have the power to walk up to somebody and ask them, "Are you having a bad day? Can I help you? Is there anything I can do for you?" You have the power of walking an elderly person across the street. You have the power just to be nice. So you can make a change. You can make this world a better place. I know you can. And I appreciate you listening to me. Thank you.
Our lungs. During this pandemic, we have found out how important it is to keep our lungs healthy. What exactly do our lungs do, and why should we care?
The job of the lungs. The primary job of our lungs is to transport oxygen from the air we breathe into our bloodstream, while taking away the carbon dioxide from our body. How this happens is when you inhale or breathe in. Air enters your lungs, and the oxygen from the air moves from your lungs to your blood. At the same time, carbon dioxide, a waste gas, moves from your blood to the lungs and is exhaled, breathed out.
The structure of the lungs. Each of us have 2 lungs in our body. The right lung has 3 rounded sections called lobes. The left lung only has 2 lobes. The bottom of each lung rests on a large muscle between the ribs called the diaphragm. The diaphragm tightens and relaxes automatically. Air enters and leaves your lungs through your trachea. The trachea, also called your windpipe, connects to 2 tubes called bronchi. Each of your bronchi goes to either the right or left lung. The bronchi divided up into smaller parts called the bronchioles. The bronchioles lead to 2 tiny sacs called alveoli.
Hi there, my name is Alyssa Beals. I am a personal trainer and a health coach, which means that I get to work with people every day and help them get healthier and stronger and teach them better ways to eat to fuel their bodies. Today I want to share with you a little bit about the Tower Garden. And the Tower Garden is an aeroponic growing system, which means it does not need any dirt to grow. That trickling that you hear is water and nutrients in that water that are coming down through and feeding the roots of those plants to help them grow. And a couple neat things about the Tower Garden is that it requires 10% of the water that a typical outdoor garden would use. We get 30% more yield, and the fruits and veggies in the Tower Garden grow 3 times faster. The Tower Garden can be set up outside in the summer, or it can be set up inside with grow lights all year round. The veggies that are on here right now, I planted in the middle of a snowstorm back in December, and we're still getting veggies off here. So I want to show you a little bit about the root system and how it grows and some of the veggies that we have growing right now. So these roots are nice and long and healthy, and they're being fed and nourished by the nutrients that are coming down, sprinkling down into that water and feeding them to make the plants healthy and strong. So I just want to encourage you to get more fruits and veggies into your diet every single day. We're supposed to get 7 to 13 servings, and a serving is the size of your fist. So we need 7 to 13 of those every single day of fruits and veggies. Like an apple, for example, would be about the size of your fist. So that would be 1 serving. And make sure you're getting lots of good water in your body and movement and exercise every day. If it's going for a walk or playing catch or frisbee, whatever your favorite thing to do. Just make sure you're moving your body, you're nourishing it really well with how you fuel it. The better we fuel our bodies with the better nutrients that we put inside, the healthier we're going to be, the stronger we're going to be, the less likely we're going to get sick. Hope to see you soon, and hopefully we'll get to check out the Tower Garden, and you guys can maybe pick some lettuce and other veggies off it and try to taste it and see how delicious it is. So I want to thank you and hope you have a great day.
My name is Ethan Laudermilek. I am a virologist at the Albert Einstein College of Medicine in New York. I'll be talking to you about vaccines today, but a little bit more about myself before I get into that. So I grew up in rural Pennsylvania on a farm, and after high school I went to Indiana Wesleyan University where I studied biochemistry. After college I went to do my PhD at Yale in the molecular biophysics and biochemistry department. And then after Yale, I came to Einstein to study viruses, and I study primarily vaccinia virus, which is a cousin of smallpox virus that you may have heard of. And this last year, I've been involved in a number of projects studying COVID-19 and SARS coronavirus 2, the virus that causes COVID-19. So first, I want to talk to you about what a vaccine is, and then we'll get into some more specifics about the COVID-19 vaccine. So, and maybe a technical level, a vaccine is a foreign substance that is delivered to someone's body that has the desired effect of training that person's immune system to recognize and fight off a specific pathogen. The reason that a vaccine works really comes down to your immune system, which your immune system is this incredible and complex system that is able to respond to infection from a virus. And in doing so, it also forms a type of memory that allows it to respond more quickly the next time you are exposed to that virus. And so a vaccine works by training your immune system to recognize just parts of the virus without ever having to contract the virus itself. They all sort of have the same what's known as antigen. So the antigen is the specific part of the virus or bacteria that your immune system is learning to recognize. It's showing your immune system a picture of a piece of the virus without having to actually encounter the virus first. So the antigen is really key to developing a good vaccine. The Pfizer and Moderna vaccines are mRNA vaccines, and in every cell in your body you have tens of thousands of different mRNA in there already. And the messenger RNA gives instructions. It's a message from your body's genetic code to make certain proteins, and proteins end up doing carrying out most of the essential functions in your body. And the Pfizer and Moderna vaccines take advantage of the fact that your body is well tuned to read instructions provided by messenger RNA and make proteins. So the way that the Moderna and Pfizer vaccines deliver the antigen is through the messenger RNA, and that messenger RNA enters into a few cells in your deltoid, and because it has the message, your body has the machinery already in place to read that message and to make the antigen. So the Pfizer and Moderna vaccine, basically the Pfizer and Moderna vaccines use your body to produce the antigen. And then once the antigen is produced, then your immune system can recognize it as foreign and can begin to form that memory. And within a few days of getting the shot, that messenger RNA that was delivered into your arm is completely degraded. It's not going to stick around in your body long term. It's not going to integrate into your genome and change your DNA or anything like that. So that is the key to the Moderna and Pfizer vaccines. They deliver an artificial message into your body that then uses your body's natural processes to produce the antigen, which turns out to be, as we'll talk about in a minute, a pretty effective way of training your immune system. So that's what a vaccine is. And what these mRNA vaccines are. And for people who don't have a background in science, it can be a little scary to hear about this new type of vaccine technology. But I want to talk a little bit about how the testing was done on these vaccines, and I know that some people are concerned about whether any corners were cut, and so I just want to talk about that. So these vaccines were developed in record time. So the reason that these vaccines were developed so much quicker was not done in a manner that compromised safety. Typical timelines were condensed. For example, typically if a drug is going through testing, you're in line with everyone else, and the FDA gets to review your application when it's your turn. But there were, these were top priority, and so there were, some bureaucratic steps that were cut that didn't really have anything to do with the testing. There was also a lot of money poured into these, and so typically it's very expensive to develop a drug, and the government was able to put the financial backing behind a lot of that. And some of the other stuff is, what we tried initially, the first vaccine that we tried worked, but that came from years of basic research that led up to this. And so some of the keys to developing the COVID-19 vaccine were developed years earlier by scientists who were working on developing a vaccine for related coronaviruses. And so some of the lessons that they learned from those efforts were able to prove to be really instrumental for developing the COVID-19 vaccine. So it was developed in a year, yes, that is true, but also this comes on years of basic research and research into related viruses that was able to expedite that process. But the way that the testing works, the key to deciding if something is safe and effective is what's known as a phase 3 clinical trial. And these phase 3 clinical trials were done, most of them had between 30 and 40,000 people. And so the shingles vaccine is a recently approved vaccine that had about half as many people. So there were about 15,000 people in the shingles vaccine. If you have 30,000 people in your clinical trial, you split them into 2 groups. One group you give the vaccine to, and the other group you give what we call placebo, which is you give them a shot so that they think that they received the vaccine, but there's no vaccine in there. It's just a shot of saline. And then you have these people go out into the community and live their normal lives, and you see who gets sick. And sickness was defined in the Pfizer and Moderna as having COVID-19 symptoms and having a positive PCR test, a positive test for the coronavirus. And so then the monitoring takes place, and part of the time to development for a vaccine also has to do with groups. Once a certain number of cases are reached, you can unblind, so you can peel back the data and see who we look at who got sick. So what happened was that 95% of the cases, in the case of the Pfizer and Moderna trials, 95% of the cases came from people who received the placebo, who didn't receive the vaccine. So what that tells you is that the vaccine is preventing these cases.